Testing. Okay.
Everyone? The morning doesn't seem to be good for everyone, I believe. So the morning is good for the Board of Governors. And what about the others? Good morning, everyone. Now it seems to be a better morning. All right, let's make this a best morning because I think we have what is best yet in store. So I'm going to request all of you to probably get a little more active. I know how it is in the morning, and I know how it is probably when you're just sitting and listening, but rest assured we have just the best speakers who are going to deliver their knowledge to us today. So gentlemen, let's put our hands together and shake our body, make some noise. Come on, everyone. Yay! We are at a conference and we are talking about future of process automation. I think process automation needs a lot of power and will happen when the power is shown. Let's begin this day requesting our Board of Governors, the steering committee members, Automation Expo South Board of Governors to please step forward. We're going to light the lamp and start this on a positive note. Gentlemen, please step forward.
Good morning, ladies and gentlemen. On behalf of IED Communications, the organizers of the Automation Expo South, I'd pleased to extend a warm welcome to all our speakers, our delegates. On behalf of our Board of Governors for Automation Expo South, we're really indeed happy to have all of you. And as I mentioned yesterday in the CEO Conclave, this is our maiden event in Chennai, but fantastic response and all of you here. So thank you once again. The next time from starting from now until 1, it's going to be a great session. We're talking about all aspects of the instrumentation and process automation. We have some 7 fantastic speakers who will share their expertise. And as Peter Drucker says, we know that the future is going to be different. And it's going to be different because the people who make technology and people who use technology, the people who are here are going to be making the difference. Thank you all.
Thank you so much, Jyoti. I'm going to hand over to Dr. V.P. Raman from now on to welcome our speakers.
Good morning, everyone. I am expecting a very positive response. Good morning, everyone. This PID is a tuned PID loop, so I want everybody to be on the tuned step. Very nice, wonderful. So today we are going to have a technically packed session, very interesting session. And I would like to start off with Mr. Binoy Kamath, who is going to be our first speaker. I will give a brief profile of Mr. Binoy. He is a very old friend of mine. Binoy is from Pepperl & Fuchs. He is the general manager on the key accounts. He is an instrumentation engineer with 25 years of experience in sales, business development, key account management, and technology promotion. He is working with Pepperl & Fuchs for the last 17 years. He is a senior member of ISA Bangalore. He has presented several papers and technology talks at various forums of ISA, field bus, and end users. He is currently involved in the promotion of Ethernet APL, which is a beautiful subject, and none other than Binoy can talk on Ethernet APL, digitization strategies in oil and gas, pharma, power plant, etc. With this, I request Mr. Binoy to please come on the stage and give his presentation. Give a big hand, please. Yeah, that's it.
Good morning, all. Thanks for the nice introduction. I also thank the organizers for this opportunity to present the real future of process automation today. So we'll start off. This is going to be a presentation on the technology, not on any product. So it's an introduction for the Ethernet advanced physical layer technology. So when we have a symphony, we have several aspects. There is control. We have syntaxes and protocols. That is the musical notes in a symphony. We have the physical layer, so the audience or the medium which we communicate with the audience. So in terms of the elements of a automation system, we have the control, the protocols, physical layer, and instrumentation. This is a basic loop of a instrumentation, so we have all these things together. Today we are going to discuss only on the protocols and the physical layer. So how did the communication technologies evolve over a period of several years? We started with pneumatic, then 4 to 20 plus hard, little bit of digitization there. Then we had the field bus coming in, serial bus plus digitalization. Now we have the Ethernet. So why do we need to evolve the communication technologies? So this is a measurement on the speed as well as on the measuring precision. With pneumatics, we had the starting point. There was a transmission speed and a measurement precision. But as we progressed towards digitization, the precision increased. The measurement precision started increase. Then the transmission speeds, that also started increasing. But with this Ethernet APL technology, we are going to see multi-fold increase in the measurement precision as well as the transmission speeds. So as we progress technologically, the handling of the devices, handling of the instrumentation started becoming complex. The user acceptance for the digital technologies is going down. But with this Ethernet APL, we expect the complexities to reduce, the user acceptance to increase. How do we do it? What are the parameters? So that is what is the next few slides which are going to come up. So how do we connect the field devices in the present day? So if you see in the automation pyramid, you have the enterprise Ethernet at the top level. At the intermediate level, again, you have the plant Ethernet. But at the field device level, you still have 4220, pneumatic, field bus. There is a lot of things which can be done. So why was Ethernet not used? Say, because the industrial Ethernet is there for last 25 years. Why was it not used in a process control environment? So what are the process industry requirements? We need to have the twisted pair cabling. Loop power devices are required. It has to reach long distances. It should also be able to be used in a hazardous area, that is in a hazardous explosive areas. It should be a easy to handle technology, and the connectors should be suitable for the harsh conditions. So this is the way we connect the devices today in a process network. You have the field devices, then it is connected to the controller, engineering station, or asset management using field bus, remote IOs, or interface barriers, or isolators, signal conditioners. So at the top level, you find that everything is on the Ethernet, but at the lower level, at the field device level, it is having several physical layers to use. So this is the first introduction of Ethernet APL. It is similar to a single pair Ethernet with power and data on a single pair of cable, similar to the industrial or the commercial Ethernet what we use. But Ethernet APL has two standards. One is defined for the communication, that is on the IEEE 802.3. Then the second standard is to handle the hazardous area, that is for the intrinsic safety. 60079-47, two wires, that is called as two-wire intrinsic safe Ethernet. So with these profiles, we have a industrial or a commercial Ethernet converted to be used in a process industry called as Ethernet APL. These are the technical specifications which are already available for use. You have the standards we discussed in the previous slide. The power supply output, you can have up to 60 watts. With field bus, the best technology so far, we have 20 watt can be handled. But with this Ethernet APL, you can go up to 3 times on a APL trunk, 60 watt power you can handle. Switch network possible. The reference cable type is type A cable, already available in the market for a field bus and many other applications. It is not going to be the typical Ethernet cable. It is going to be the type A industrial cable. Maximum trunk length up to 1 kilometer possible in a zone 1 environment. Maximum spur length 200 meters. If the field bus, it was only 120 meters. So here you get up to 200 meters. The speed is going to be 10 Mbps. So foundation field bus, which is the fastest current process network, is 31.25 kbps. So Ethernet APL is going to be 300 times faster than the foundation field bus or the Profibus networks. Hazardous area protection, yes, for all zones, divisions, it is possible to be used. So the work packages for this technology, for the end users to use or the product developers to use, everything is available. For the communication, there are one standard already there. Power and cabling standards, yes. Intrinsic safety standard available. Conformance testing, this is for your interoperability test. Multiple vendors have to work together and function together. So that testing is also there. Then engineering guidelines for the end users, EPCs, consultants, that is also available currently. So the future of the process plants is going to be the Ethernet infrastructure. You see here the devices, they are all communicating on an Ethernet-based network. At the top level, engineering station, controller, and all other applications are on an Ethernet. So through and through, right from the field device level to the enterprise level, we are going to have a Ethernet physical layer. So we will not have different types of physical layers in different levels. So through and through, from the field device till the cloud level, it is all going to be the Ethernet. So this is going to be the OSI module. The earlier ones you see here hard, then you have the FSK. Then with the Profibus and the field bus, it is Manchester bus protocol. And with the Ethernet APL coming into picture, you have Ethernets through and through. At the physical layer, you have Ethernet APL. At the data transport layer, you have TCP IP and Ethernet again. At the application layer, you have Profinet or Ethernet IP. So everything is going to be on the Ethernet. So this is our typical Ethernet cable, which we have all seen. So this is going to look like in a process plant with a type A cable. We will have 1 kilometer distance, which is required in the current plants. Then EX is possible, that is a hazardous area management is possible. High power is possible, then 10 Mbps is the speed. So explosion protection, a note on this, so we have a standard 60049, so -47. This is defining the interoperability as well as the planning and installation of the devices. No validation, special validation of intrinsic safety is required because it is all built in within the APL switches and the distances. So it is similar to the FISCO, the same concept is used, what was used in the foundation field bus, but the physical layer is going to be the Ethernet APL. So these are the typical layouts. You have the star topology for smaller plants for up to 200 meter spur length, and trunk and spur. This is the chicken foot topology, what we call for longer distances, for up to 1 kilometer of cables. So different topologies are possible with the Ethernet APL. So the required components for a APL network, the APL field device, currently it is all under development, but you can use a Profinet or a Profibus device if it is available. So we need a field device, a APL switch, a controller, and a engineering and configuration tool. So you just connect the device, the switch detects the device, the IP address of the device, and through a web interface, you can get all the data of the device which is getting connected. The physical layer diagnostics, the device information, the current status of the device, it is all coming from a HTTPS web interface, not any special software. No special DCS software is required. It's all coming on a web interface henceforth. So a typical tank, when applied with the APL device, how it does. This is an actual measurement which is happening in the lab. So the example is verification of tank volume on two Vega Pulse devices. One is a HART device and another one is a APL Profinet device. So with the HART, every update here is taking 2 minutes. With the APL, you have 2 seconds, one update is coming. So you can see here, so it's a live screen. So the HART update is going to take quite a bit longer than the APL. This is the speed which we are getting from the Ethernet APL live devices. So no more time for coffee in between taking 2 readings. So those things are all eliminated. The technology in the field, today you have pneumatic, analog, all mixed. We will just see the high-speed digital current one, field bus. Technology is field bus, communication type is serial plus digital. But in case of Ethernet, this is a true digital transformation. This is going to be the future. No analog involved in this. So even the field bus has little bit of serial, but here with the Ethernet, you can have concurrent access to all the data. It's gaining acceptance among the end users. So you have, for the device integration, complete one single repository you can access on the Ethernet. It is used for all devices in operation as well as in use. Simple maintenance and update of the database of the field devices. So the complete device fleet can be managed using in a quicker way. So another measurement, so with how do the bandwidth of 10 Mbps help? So with HART, we have 1.2 kbps is the measurement speed, 31.25 kbps with Profibus and Fieldbus. Ethernet APL is 10 Mbps. For a upload and download of a Coriolis mass flow meter, this is what is the data we are having. In the actual testing, with the HART, it is 8 minutes. With Profibus PA, it is 3 minutes of upload and download. With Ethernet APL, it is 10 seconds. So this is the level or this is the speed which we are getting in the laboratories as of now. So reducing the complexity, how we do it with the Ethernet APL. So you had the measured value in pneumatics. Then you have in the 4 to 20, again, measured value plus device information. In field bus, you have measured values plus device information, but field bus is always considered as bit complex compared to the other. But with the Ethernet APL coming into picture, the complexity is going to be reduced because you have all the data already available in your repository. Then we are sure the end users will also accept the ease of use, the speed, and other features of this technology. The engineering guideline, which is already published, it is there in the Fieldcom website. It gives details on the components, the switches, cables, field devices, several applications, several pilot plant applications, they are there. What are the power considerations to be taken for your plant, that is defined. Installation guidelines, how do we lay the cables, what are the routings to be taken care, complete details are provided. Then there are migration examples, including some portion on the digital twin, that is also mentioned in the APL engineering guideline. So the basic guideline or the basic ambition of this technology is to reduce the risk, simplify the design, and accelerate the deployment. So these are all, the technology itself is not created by one company. It's a consortium of about 40 companies. The main drivers are Fieldcom Group, then Open Device Vendors Association, OPC Foundation, and Profibus. And ABB, Emerson, Anderson-Dowser, Pepperland Fuchs, Siemens, Rockwell, Yokogawa, all DCS vendors, all field device vendors are all part of this technology development. So this is a lab in BASF, Germany, where there are about 1,000 different field instruments. All DCS types are being tested in this lab. So it is already ready for deployment. So this is the recent news, 14.4. So we have already the tests are successful in Anderson-Hauser facility, where Honeywell and ABB DCS have been tested with about 1,000 field devices in the last 2 months back. This is a load test to fully load the Ethernet APL network and test for whatever we showed in the previous slides. 10 seconds of upload, download, 300 times faster than the field bus. So this is the final test was done, and now they declared that this technology is ready for actual deployment in the field. Some of the customers who are showing interest for a test bed or a pilot plant, in India we have Reliance and then a few other companies who are very much interested to have a test bed. So the next thing for you is to contact the experts in different companies who are part of this technology group. We have a demo unit available in our stall B5. Everyone can visit after this conference and have a live demo. Then we encourage you to have test bed or pilot plant in your sites or facilities. So in summary, Ethernet APL is a robust and rugged technology for Ethernet, which fulfills requirement of process industries for today and many more years to come. So finally, the symphony, it is orchestrating your instruments, value of protocols and syntax. Then you have the physical layer, which fits exactly to your requirement. Thank you.
Thank you very much, Binoy. Thanks a lot. It was a wonderful presentation. Now, any of you have got any queries, technical queries, can please raise. We have got time for 1 or 2 queries. Yeah. Please say your name of the company and the question.
Hello everyone, I am Deepan Chakravarti from L&T Rubber Processing Visionaries. I have this question, like we have been using ASI technology. Hello, sir, can you hear me now?
Yeah.
Yeah, means there is a technology, that ASI technology, where both power and signals are transferred in the same cable, which was very useful for us in our conveyor systems and other automation applications. Do this Ethernet APL technology also have the same power and data can be transferred in the same cable?
Yes.
Because
ASI is for basically for the factory automation. So this Ethernet APL is similar to that. You have the data as well as power on the same cable can be transmitted.
Yeah,
that was the first slide.
Okay, sir, that will be very useful, because in case of normal Ethernet, we used to take 2 cables, one for communication, other for power.
Yeah, so that is what the 2-pair cable of Ethernet is now made for the process industry, where the data as well as the power is on the same network.
Thank you very much, Binoy. Anybody else has got any question? Yeah.
Good morning. I am Pugalindi from ISRO Sriharikota. We already had the opportunity to test this APL at our plant. We thanks to P&F team, the Chennai team. So
With
they
Siemens,
offer the demo product to us.
Yeah.
So when we do the testing with the Siemens hot standby PLC, we face a little bit problem on this profile mismatch on the field instruments to your APL. So then subsequently your team has guided us, and then we updated the profile of the instrument, thereby it could able to these things. Is there any plan to standardize that profile?
Yeah, so that is what is all this technology. I told the load test which has been performed recently 3 weeks back is to overcome all these profile issues. Okay. So once you have the data, or the device data in the repository, it is easy, it will just plug and play.
Okay.
So right now we have some hiccups. DCS are not ready or the profiles are not ready, but with this load test we have it fully ready and it means now it is ready for deployment. So what you did was 6 months back, the testing.
Yeah.
So now it is fully ready for deployment, and if you have all the updated device data, it can be just plug and play.
Okay, and one more, you provided only in the chicken food topology network. Is there any problem with the ring topology, because Ethernet primarily for the ring redundancy, all sort of things to establish?
No, it's there. Media redundancy protocol is built in the this thing in the switch. So what we provided you is a demo unit,
Okay.
just to check the technology.
Okay.
So if you want a full-fledged one, that's what we are encouraging people to make a test bed, and you can test it with full redundancy and actual devices.
Okay. Thank you.
Thank you very much, sir. See, Binoy is available, install B5. Any further questions can be discussed with Binoy directly. I have one question. Is it possible to do the migration from the existing foundation field bus device to Ethernet APL?
Currently, no,
Okay,
but there are pending works which is happening.
okay.
And there is a committee to look into that migration application. So probably 2 years, 1 year, 2 years down the line, you will have something like gateways or something for the migration. Right now, no.
One more point was you mentioned about the segment as 200 meter, but you did not mention how many devices can be connected per segment.
Each spur is 200 meters,
Yeah,
and it is unlimited.
unlimited.
Yeah, the
The
spur
speed-
is unlimited.
The speed will not be
No,
compromised.
it will not be.
Okay,
It is the concurrent use of the speed.
thank you. Thank you very much.
Thank you.
Thank you very much. Thanks a lot. Please wait, Binoy.
Thank you so much, Mr. Kamath. We couldn't find a better person to felicitate our speaker other than Dr. Thampi Matthew himself. Sir,
Mr. Sai Ramesh, I would
oh yeah, we're
request,
South BOGs.
I request Sai Ramesh to please come forward and honor Binoy. Please give a big hand. Please give a big hand. So our next speaker. I'm sorry. The next session is from Divyang Shah. Divyang Shah will be talking on OPA, which is again the latest subject on the process control. I would like to give a brief profile of Divyang. He is a group lead instrument reliability center in the excellence in Reliance Industries Limited. He holds a Bachelor of Engineering degree in instrumentation and control and has 29 years of experience. He has been with Reliance Industries since 1995 and he moved in 2014 to the Center of Excellence in Mumbai and is responsible for reliability engineering and asset management of control system, rotary controls, OT, cyber security functions, etc. He is leading a team for evaluating, testing, and implementing new technologies, including open process automation system. Divyang's activity include publishing cybersecurity internal standard, FEMA reports, BMPs, and driving implementation of them. He is also engaged in the digitization of projects, managing obsolescence of control system upgrades, and resolving reliability issues across all Reliance sites like refinery, petrochemical, polyester, etc. With this, may I now request Divyang to please come on the stage and give his presentation. Please give a big hand.
So good morning, everyone, and thank you, Ramanji, for this generous introduction, and I thanks Heidi for giving this opportunity.
We'd like to inform everyone that we'll be taking questions at the end of each session, so please feel free to make notes and our speakers would answer accordingly.
Okay, so today I'm going to give you a brief introduction on open process automation system and what Reliance is doing in this field. So these are the agenda points. We'll go through all pain points we were having and why we joined OPAS to address those pain points, what we are doing in this OPAS technology, and then finally we'll wrap up. So as you are aware, Reliance, there are three major groups: Reliance O2C, Jio, Digital Life, and Reliance Retail. And in all the three fields, I think we are the leaders in India as well as at the global level. So we'll just skip these introductory slides of Reliance because I think everybody is aware of what is Reliance and how the Reliance performance is. Okay, so we'll talk about this Reliance vision to be net carbon zero by 2035. So we are putting up a solar photovoltaic module factory at Jamnagar. We are putting up advanced energy storage, battery factory, electrolyzer factory, and fuel cell factory at Reliance Jamnagar to become a net carbon zero by 2035. So these are the growth engines of Reliance. Robust and consistent earning, you can see the profit and PBDIT as well as revenue is increasing over the years. Okay, so we'll come to the technical points now. We'll discuss with the Reliance pain points, why we joined OPAS. As you are aware, we have multiple refineries, petrochemicals, and polyester sites across western region of India. We have around 5,000 plus control systems working across these sites. So what are the problems we were facing with these control systems? So one is a digital transformation. So we are moving ahead with digital transformation, and as we are aware, digital transformation is requiring a lot of data from the OT system. And what we found is legacy control systems are constrained because they are not able to provide the data at the required frequency and the number of data points to the cloud to manage predictive maintenance or early event detection kind of thing. New features cannot be introduced in the legacy system. Suppose if you want to add a multivariable controller into the legacy system, it is not possible. So you have to add on some applications, or you have to upgrade the control system. Third point is related to the frequent obsolescence of Microsoft OS. As you are aware, the obsolescence of OS is a big issue for OT control systems. Once it is declared obsolete, we don't have patches available for cybersecurity purpose. Then if we want to upgrade the control system, we have to upgrade it with every obsolescence of OS, and that period comes to around 5 to 7 years based on our shutdown frequency. So if you upgrade all the control system in every shutdown, then the capex cost is very high, and it demands, the profitability is going to reduce, because if you want to upgrade each control system in every shutdown. Next point is related to cross-platform upgrades. So once you upgrade from, suppose, ABB to Yokogawa or Yokogawa to Honeywell, you have some programs written into the DCS which are in intellectual property, of the Reliance, and then you have to make it exposed to the world, because you have to rewrite those programs. Very high cost of upgrade is going to reduce the profit margin. Competency build up after every upgrade, you have to do that. And then all the control systems are having a bolt-on cybersecurity. The security is not built into the applications. So what were the motivation and benefits when we joined Open Process Automation Forum? So as I discussed, the operating profit, the major point was the operating cost and capex for upgrading the systems. So it is going to bring down the profitability. Second point was related to the systems are closed. As we discussed, if you have to put some new feature in the system, we have to upgrade it. And the flexibility of getting the data from OT system to IT system was not there in the legacy systems. Third point is related to cybersecurity. As I discussed, it was a bolt-on kind of thing. We have to put extra tools of cybersecurity on the system, control system, to provide the cybersecurity to the control systems. The motivation behind joining OPAS, the main objectives of OPAS were to have a completely vendor agnostic system. You can get the devices, softwares from the best-in-class available from the market, integrate it, and then use in the to control the plant. So easy migration and upgrade path, certified software and hardware component interfaces. So OPAS is going to have a certification for all the components. Multi-vendor operability, you can select the best of the devices from the multiple vendors available in the market, integrate them and use for the process control. It is a future-proof, as and when the new features are getting added to the control system, you just add it on the existing system. There is no need to upgrade. And then holistic security framework. So OPAS, one of the objectives of OPAS is to bring in built-in cybersecurity. So I think the OPAS is going to transform the process automation industry. So reduce the cost of control system upgrade. You don't need to upgrade the complete control system in one go. Increase value generation by removing barriers, and design for adaptable cybersecurity. So as you can see that, pointer? Okay. So in the right side of the diagram, as you can see, there is an open process automation systems architecture, where the boxes with golden color, they are the open process automation compliant boxes. So these components are going to be certified by OPAS. The blue boxes are the part of legacy control systems, and then you will have a gateway, either gateway or interface devices to interface them with the open process automation system. The OPAS connectivity framework, which is the central bus, which is used for communication between the different nodes of control system, that is OPC UA based. Yeah. So this is the OPAS connectivity framework, that is OPC UA based. And this is the OT data center wherein you can go for virtualization, complete virtualization, and then all the applications will be running on that. And this is the business platform interface. And these are the blue boxes which are of legacy control system and non-OPAS compliant. So we have 100 members in open process automation forum with 20 plus hardware and software suppliers, 5 major DCS suppliers, 10 end user collaboration partner, and out of 10 collaboration partners, 7 have already announced a test bed facility. So what are the versions which OPAS has already released? So version 2.1 is the latest, which was released in 2022. Version 1 was released in 2019 with interoperability theme. Version 2 was released in 2020 with configuration portability as a theme. 2.1 was released in 2022 with control functionality as a theme. And version 3, we have already started work on version 3, which is going to be released either at end of 2023 or next year, with application portability, orchestration, and physical platform. So what is application portability? It ensures end users have the ability to move their apps, whether customized, custom development, or vendor provided, from platform to platform, as well as to use any process automation software regardless of vendor. So basic theme is, you take a HMI, if you want to upgrade one HMI to another platform, you just take a backup and reload it into another vendor's station. So that will be completely vendor agnostic kind of thing. System orchestration ensures the ability to select and implement OPAS certified products from multiple suppliers, and to be assured those products will coexist seamlessly in a unified open process automation system. So you have multiple devices from multiple vendors, and then how do you control those devices? So system orchestration is going to help, starting from the implementation phase to commissioning, decommissioning phase. So everything will be gone through system orchestration. And then physical platform that ensures end users have the required degree of openness, interchangeability, interoperability, and security across platform within system. So these are the basic fundamental devices of open process automation system. DCN is a distributed control node, and this is applications which are running on the DCN. So you can have multiple types of DCNs with, one is only control mode of DCN, control with IO, and the third DCN will be having only IO interfaces. So OPAS certification program supports multi-vendor marketplace for OPAS products. So this is going to be released in, I think, July 2023, the first phase of OPAS certification, where formal validation process, it is going to be managed by Open Group, and they are going to put up a third-party services, third-party labs accredited by Open Group to test out the open process automation devices. So products that demonstrate conformance to 100% of the OPAS requirement receive certifications and will be listed on the website. So there are multiple interoperability tests are getting organized by open process automation system. There were 2 such events which has already taken place. One was in 2019 and second was in 2022, wherein vendors sits together and tests out their devices for interoperability, interconnectivity point of view. And based on this test, they modify either their product or they give input to the standards to for any update or modification point of view. So 14 organizations participated. This were the organization participated in 2022 interoperability event. So So how do we adopt this open process automation system in brownfield as well as for the greenfield projects? So this is the open process automation architecture. We will go through how it is going to be helpful in brownfield as well as greenfield project. So this is open process automation scope. We are not touching SIS at present. Only DCS, HMI, IO, PLC, HMI and PLC IOs are getting, will be handled by OPAS system. So we have a DCS IO and PLC's IO which can be replaced by DCN with application and DCN compute module. We have application running in controller that can be represented by application in open process automation system. So this bus will be replaced by OPAS, Open Process Communication Framework, that is OPC-UA based bus. And this total HMI and engineering station and application network can be replaced by advanced computing platform where all applications will be residing in a virtual DCN. So this system will look like this system in OPAS. So suppose if I want to add a open process automation system devices in the existing network, so how it is going to added. So we'll extend this bus and connect a DCN which will work as a gateway to the open process communication systems bus. This will be OPC-UA bus and this will be a proprietary bus with which will be connected through DCN. And then as you start upgrading as you start moving from the legacy system to open process automation system, you can replace IOs and controllers through DCNs. You can put up the ACP and then move the applications from this platform to this platform. So this is the total migration from legacy system to open process automation system. Now we will see how open process also automation system is helping from Lobsolon's point of view. Suppose there is a device supplied by supplier X in open process automation system and it has been declared obsolete by supplier X. So what is the forward path? So what we will do is we will go to the market, we will select the best available device from the market, we'll just bring it and replace it. Just take a backup from the legacy system, DCNX, and put it in the DCNY. It is interoperable, interchangeable, and it will just connect to the plug and pay type thing. Okay. So this is the RIL participation updates. So we joined OPAS in 2018 end. And we have a 13-member team, so specifically working on open process automation system. We are participating in the subcommittees of open process automation system. There are around 8 to 9 parts of standards where the OPAF is working on those standards at present on version 3. So we are participating on these standard committees. We have internal meetings to review the OPAS MOMs, the subcommittees MOMs, and how do we give our inputs for updating the standards. We have participated in end user caucus and provided excellent inputs for the 3 standards which are going to come for orchestration, application portability. And we are participating in the outreach activities like what I am doing just now. We are also going to do presentation in ISA forums. So we are a part of collaboration partners with end users. There are 7 end users who are working as a collaboration partners. ExxonMobil, Aramco, Bosch, Dow, Shell, Georgia Pacific, ConocoPhillips, and Linde. We are meeting every month to discuss the test bed scenarios and how they are progressing in test bed. So some of these have already put up the test bed, like ExxonMobil, Aramco, BASF. They have already put up the test bed at their facilities. So we are discussing on the products and common topics of interest and future topics like HMI portability, integration requirement of PLC, SDs, and fast multi-point controllers. Now we'll talk about the RIL test bed updates. We have already put up we are planning to put up the test bed. We have already selected the system integrator. Yokogawa is our system integrator. We are going to get our test bed by July 2023, and then we are going to test all the use cases we have prepared as well as our requirements in that test bed. And based on the success criteria or the test results, we are going to update the forum to update the standards or the problems we are facing. We are going to give the feedback to the subcommittees. So this is the test bed architecture for Reliance. So we are just starting with few DCNs, and then there will be a HMIs and historians, engineering software and system management software available, and then operator station and engineering station. So this is the open process automation prototype deployed by ExxonMobil in one of the facility at Clinton, New Jersey. So this was tested for 6 months in the running plant, and then it was removed, and then old system was re-established. BASF has also done such demonstration in for chemical industries. So this is the ExxonMobil open system prototype developed for pilot unit, what was there in Clinton, New Jersey. So the aim of this test bed development is we just do the test bed development and go for a field trial, and then based on the developments and field trial, we ask vendors to come up with the OPAS compliance products, as well as we give feedback to the open process automation forum to develop update the standards based on our findings. Okay, so this is the end of presentation. I think we request all end users and manufacturer companies who have not joined Open Process Automation Forum to join, to be part of this journey, so that we can go to this disruptive, we can implement this disruptive standard in next 2 to 3 years in plants. Thank you.
Thank you very much, Divyang. Any questions from anybody? Yes, please.
Sir, good morning. I am Sivaramakrishnan from SGS Ishar. Sir, why SIS systems are not part of this? You are removing it actually. I just want.
At present, SIS system are not considered a part of the open process automation scope, because at present we are selecting OPC UA as a communication bus, and then we need to test out for the deterministic response kind of thing for which is required for OPC, SIS thing. So that's why we have not kept it as a part of a scope of OPAS at present, but it will come in future.
Okay, thank you. Anybody else has got question? Yeah, 1 second.
Good morning, sir. I am Pugalindi from ISRO, Sriharikota. The OPAS, the framework you said, the OPC UA. OPC UA is exist for so long time, and many such controllers are offering with OPC UA. So what extra we are getting from the OPAS?
I could not hear you.
Sir, OPC UA is a framework for the OPAS. OPC UA is exist for many years.
Correct.
What extra benefit we are extending from OPAS?
No, we have selected OPC UA as a basic communication bus for open process automation system. It is not that only OPC UA is feasible, but at present all the test beds and every end user is working on OPC UA based communication bus. So OPC UA is going to be a future standard for communication, because now the field communication is also getting developed on OPC UA. So we can directly connect the field instruments to OPC UA bus, and then we can get a control. So then there will be no need of DCNs, intermediate DCNs will not be required.
Like OPC UA framework already exists now, sir.
Yeah, it is existing, but we have selected it as a
No, is there any advancement you are doing on this OPC UA to
I
match
hope-
with the OPOS?
correct. So OPC UA provides the functionality of security also. That's why we have selected OPC UA as the framework. OPC UA provides encryption as well as authentication level of security. So that is going to be used when the final system based on OPAS version 3 will be delivered.
Okay, thank you.
Thank you very much. So now, Divyang is available here. So any further question can be discussed with Divyang directly. So now let us take it forward. May I now request Mr. Thampi Matthew to please come forward and honor Divyang Shah.
Let me give a big hand to Divyang. Actually, we could get a person like Divyang who has been the Reliance company ka means it's Hindi, company Uday in Tamil, reliability leader. They have the largest plants and he has been proven his mettle 20 years plus, and he has been the leader of the reliability and the future technology to get adopted to get better reliability for the plants. So give a big hand again, and we are blessed today because of his presence.
Now we continue our next session. Peslamana? Very good. Being in Tamil Nadu, I think I should speak in Tamil now. Our next speaker, அடுத்த technical lecture வந்து ஹரிஷ் வாத்வா is an old friend of mine. அவர் வந்து ஃபீல்ட்காம் குரூப்ல இருந்து டெக்னிக்கல் ப்ரெசன்டேஷன் கொடுக்க போறாரு. FDI single approach to device integration. Please welcome Harish Wadhwa with a big hand, and I would like to give a brief profile of Harish Wadhwa. Harish Wadhwa takes care of regional marketing activities of Fieldcom Group in India. He is also the Vice President at Chemtrol's Industries Limited, a company in the field of terminal automation, analytics, flow automation, process control instrumentation, and steam engineering. Fieldcom Group is a global standard-based non-profit member organization consisting of leading process end users, manufacturers, universities, and research organizations that work together to direct the deployment, incorporation, and implementation of communication technology for the process industries. FCG are originators and custodians of technology like HART, Foundation Field Bus, and FDI. He has more than 35 years of experience of process control instrumentation and has worked with reputed organizations like Anderson Hauser, Nivo Controls, etc. He is a widely traveled person with experience in concept selling, projects, key account, sales, and marketing. He is a postgraduate from Birla Institute of Technology Science, BITS Pilani, with specialization in marketing, and from DAVV Indore. With this, I welcome Harish Wadhwa. Harish, please.
I hope whatever Raman spoke about me in Tamil was all good, because I'm sorry it is Greek and Latin for me. But thank you so much, Raman, for inviting us and, of course, giving my introduction. At the outset, I would say IED has become a growth engine for promoting process automation here in India. And undoubtedly, I think they have been giving an exposure to the fraternity, first, say, from Mumbai, where they hold their annual event, and this year from the South as well. So a big congratulations to IED for venturing into the South. Another problem I see is when you are later presenter, some of the slides that you wish to present are already presented. So please bear with me, because at the last minute I am not able to kind of delay it, because some of the concepts have been already spoken about from Binoy, and even Devyang touched many of the subjects and pain points which you are going to see in the slides that I'm speaking of. Okay. I must confess today that, or rather we all know, that we are living in unprecedented times. Times where the technology is changing, times when the products are changing, times when the mindset is changing, and the times that my dear country is also changing. And I think with the kind of bandwidth that today India has, I think we should be able to take a lead and set our foray into the new technologies as early as possible, become the early grabbers to be sure that, yes, we can prove that the technology works for India and the worldwide. There are many, many technologies that are emerging, as you will see, and you have seen also. But the key to all the success of all these is interface. So I'm going to touch about a topic which is related more to the interface of devices to the host systems, rather than really talking of the nitty-gritties of the physical layer. Something that Raman introduced, that we are from the Fieldcom group, and we are a global setting organization, which means that the concepts like Ethernet APL, which Binoy talked of, or FDI, which I'm going to talk of, or even HART IP, wireless HART, we are custodians of the standards for this. So we basically write the standards and become a repository. And yes, the vendors and the host systems then comply to that to ensure interoperability, easy interface. The gentleman talked about interface of some device and some difficulties that you face in ISRO. Well, these are small nuances or pain points, but when you have standards which cut across each and every one of us, then you can be 110% sure that the system works, and works flawlessly and the very first time that it gets connected. Why is it not moving? Okay. Sorry, it moved too. Fieldcom, just 2-3 slides, not much about the Fieldcom group, that we have about 400 members across the globe, both from the vendor side and also from the host side, and also from the vendor or the physical layer side. And as you can see here, these are the technologies that we hold the custody for, and we write standards. We have an active chapter in India, and please feel free to join us, get in touch with us in case you need any more information or videos or any documentation. We do not work alone. We work in collaboration with many companies, like you can see OPC, Ethernet IP, ISA, and Namur, Modbus, PI, FDT Group, many all of these organizations. And for device integration, of course, we have collaborating members who work on day-to-day teams or work on work groups, basically to test the technology, develop the nuances, and then document and move forward. Where ABB, Emerson, Anderson Hauser, Honeywell, Schneider, I mean, there are many companies. These are part of the working group for FDI. And of course, there are others also whom we collaborate with. So you will see practically all the big names who are collaborating with us in terms of writing these standards. So coming to the topic of today, device integration. And I mentioned a little while ago that if you wish to have the least of the pain points when you interface a device with the host system, well, the standards play a very, very vital role. And we have taken a long journey, I would say, where we had these current-based devices, where everything was peer-to-peer. I mean, all of them in a multi-core cable and coming to the marshalling rack from where, of course, you could take the control action. Then came the days of field bus. In basically field bus, I would say many devices were interconnected on the standard 2-wire cable. And of course, it was being powered by the 2-wire, and also the signal was being taken. So you had foundation field bus, you had profi bus, you had many other standards like these, which were there in the play, but of course, IFF outplayed many of them. Then came the era of wireless devices, where many devices were connected to each other wirelessly. And through a router, of course, the data was sent to the control room. This was by and large for the monitoring application. Technically and technologically, it is possible to do a control, but nobody would dare, obviously, because, I mean, you do not want to take a chance with a process plant. And therefore, by and large, this wireless technology was used for monitoring. Now comes the bigger picture, that we already have devices which were on HART or current. You had foundation field bus, you have wireless HART, but you have to integrate all of them. And when you integrate all of them, you need many, many things with each of the devices. So the devices that you see here are basically different from so many vendors. Reliance, Devyang talked of so many control systems, almost 2,000 plus controllers in their field. Now, obviously, I mean, there are so many devices, so many control systems, I mean, all coming from different era, from different timelines, from different manufacturers, from different technologies, all need to be integrated. And therefore, the need to have one system. This is a slide that Binoy also shared, but just to share with you that Ethernet APL will become the next standard, again, as a physical layer into the field. And yes, you will see the advent of this, but again, it boils down to the same question. You have devices which are 4 to 20 milliampere based, you have you can say, smart devices with the heart, and then you will have field bus foundation or, I mean, those kind of devices. But the next one, Ethernet, and all of them would have their own set of devices. And remember the fact that no manufacturer or no user would ever like to throw out their legacy system. It is a misconception that you can come up with a new one and throw away everything else. It doesn't happen. Whether it's a brown field or a green field, you will always see a hybrid system where you will have a mix and match of many, many such systems put together. All the reason for having a good device integration. I think Devyang also talked of, you know, why do we really need these standards? Why do we really need to work with these kind of new technology? Obsolescence of the Windows platform. I think Devyang, you very well and very aptly said so, that with the advent of these changes, today we're talking of Windows 11 and there's already a 13 which is under working. So as times change, upgrading all these operating systems for a company is a Herculean task, plus buying the licenses plus having the patches to make sure that the device integration is seamless. The same thing applies for other devices. And so the basic motivation for us to go with FDI is to basically reduce the life cycle cost and enable an architecture which was accepted by NOAA, that is Namur Open Architecture. All this is very critical because there are people who are already used to a certain level of system, and you need to make it simpler, something that again Binoy talked of, that with the new systems, you need to reduce the complexity as much as possible and make things easier for the operator to work. So is FDI really a new protocol? The answer is no. FDI has been in existence. Of course, it's being upgraded with the new versions, and I will show you some of the examples of that. Then will FDI support hard devices? Obviously, yes. It will support not just hard, it will also support all the other protocols. That means for every device, whether it is a pressure transmitter, a Coriolis meter, or any kind of a system, you will have, I would say, I mean, on any of these protocols, maybe HART, wireless HART, Profibus, or foundation field bus, or in future HART IP, but all of these, how many systems do you really want to keep in your asset management system? All this will go, and you will have only one software package called the FDI assigned to a host and assigned to a device, which will then make a seamless integration. Once you do the handshake, the device is automatically connected to the host system without really the need for any more software packages and version numbers. I'm sure Reliance suffered a lot when it came to the version numbers. Every time FF came up with a new version number, it became a big havoc. and how to really download that again into the device. That problem is going to get solved by Ethernet APL. And you need not really keep any track of the version numbers, because the one FDI that I'm talking of is going to be downwards compatible. So you use the present one, that will also stay in the web server, in your plant, and of course in the repository with the FieldCom group. You have the devices connected through the web server into your host system, and the data is picked up practically automatically. This is going to be the future, and for that matter, something that we are all looking forward to. Just to now, instead of me rattling out some things about FDI, I thought let me just give you a very, very short film, just about a minute or two, about what FDI is all about. There's no voice? Check.
What is FDI? FDI is an internationally standard
voice is not
solution
coming.
for process automation, device, and systems integration. What is FDI? FDI is an internationally standardized solution for process automation,
increase the
device,
volume?
and systems integration that dramatically simplifies software installation and maintenance, as well as
हाँ, ये। इसको बढ़ा दीजिए, full कर दीजिए। हाँ, ये। हाँ, okay। हाँ, click करें।
What is FDI?
Sorry।
FDI is an internationally standardized solution for process automation, device, and systems integration that dramatically simplifies software installation and maintenance, as well as communication between enterprise-level systems and technologies on plant floor. Before FDI, individual devices often came with hundreds of files to address different systems, configurations, and interfaces. With FDI, a single device now uses one file to provide data and process values to all systems. An FDI system is made up of two parts, an FDI device package and a host system. The FDI device package is a standardized container of all files necessary to describe a field device to a system and a person, including the device description, user interface, and device documents such as wiring diagrams, manuals, certificates, etc. All of these elements are packaged together in a digitally signed FDI device package. An FDI host system in process control can be a DCS, PLC, an asset management application, or even a configuration tool. FDI host systems are made up of an FDI client and an FDI server. FDI hosts may also provide an OPC UA interface to field protocol communication servers, thus allowing disparate machines and systems to communicate. The communication server is the key element enabling FDI to be broadly adopted into the IIoT and Industry 4.0 initiatives. In particular, the server enables local or cloud-based OPC UA connections, which simplifies integration with existing IT infrastructures. FDI and OPC UA deliver access to plant data from across the globe, allowing corporate offices and subject matter experts to optimize assets and stay ahead of the competition, all while providing built-in data security. FDI and OPC UA enable the digital transformation of process plants to work more efficiently and effectively with fewer resources and tighter constraints.
Well, there is a website available where you can even get this, and if you write me an email, I can even send you all these movies. There are lots of them available. So the key highlights of this small presentation was that you will have only one package for one device. Not many, no version numbers, nothing is required. The latest one would be downwards compatible, and anything that is coming from even the legacy systems will need to be incorporated. Of course, connecting to any communication protocol. We just saw that whether it is foundation field bus, whether it is Modbus, whether it is HART, HART IP, wireless HART, anything, and even Profibus, for example. I mean, all of them would be contained into this only one device driver package called the FDI. And of course, the FDI server, which is in the plant itself, would be a repository for all these drivers. And once connected, it'll pick up the data from that relevant FDI and take it forward. So are there host systems? Yes, there are many host systems like Emerson, like ABB, Yokogawa, many others, in fact, who are already there. But yes, also to share that many of these host systems are also now certified by FDI. You remember that tick mark with the FF devices? You're going to see the same thing with the host systems and also the field devices, that this FDI is an approved and attested one from the Fieldcom group, which means you have seamless integration, you have seamless interoperability, and of course, many added advantages of integration that you normally face in the field. Is it new that, or is it only one company which is actually doing it? Not really. There are almost about, I would say, 100 of them really into the field, into the testing labs. And for that matter, many of them have even been, you can see here that there are many of them which are already registered with the Fieldcom group, and the testings are going on for many other host systems as well. Just some examples that many of these systems are already FDI certified. Now, this is something that we just talked of a little while ago, where the data of the device, the FDI package, would come to the FDI server, and this is a net-based server, an HTTP server, from where the data can be picked up either by the client for data analysis, for the cloud, or whatever. So just one FDI server will be able to take care of all the integration needs for a plant. The core of the FDI has 3 packages, something that you saw a little while ago. The EDDL, which is basically the machine language, which tells you what the device is all about, what data it's going to give out, in what format it will give out, in what bits it will give out. So all the data, the technical data, is given by the EDDL, the electronic device description. The UIP is basically the software interface. If you have seen radar devices, or if you have seen time-of-flight devices, you get what are known as those envelope curves, reflection curves, or even for a valve, you get signature of the valve. All those graphics will be available from this UIP package. And of course, no need to keep the manuals, no need to keep the CFF files, no need to keep the other GSD files. All the data will be available from the docs. That is, all the hardware data about that particular device will be available at every point of time into this FDI package. Okay. So FDI host, this is also forward focused, and it is backward compatible. So that means once you have the latest one, all the previous devices will automatically get connected. That is a basic theme of using FDI or insisting on FDI. There is a website called Ask for FDI, and I humbly request each one of you, please do browse through this website. It'll give you a lot of insights and what work is getting done, in terms of developing these FDI packages. Insist on a registered mark, something that I just mentioned, that like FF, like other devices, now you will have a red tick mark. And if the red tick mark is coming from the Fieldcom group, that means it has been tested in those work groups, something similar to what you are doing with OPAS. There was a recent one in Singapore, where there were so many manufacturers who had come with their devices, sitting across the table to see whether there are any bugs or there are any issues in terms of interface. From the host systems, of course, to the control devices. So insist on FDI packages as a part of your basic need when you come to the plant offerings, because only then you can be sure that the integration is seamless. Well, FDI also supports a NOAA open architecture, that is Namur open architecture, something which has kind of become a de facto standard. You know, Namur is basically an organization of all the chemical companies of Europe, and even others, many outside. So the core philosophy of Namur is that please don't touch our existing system. Build on it. Build on it by having a diode, a NOAA diode, which will give the data from the field devices to a higher level. from where you can actually then connect to the OPC UA and then after retract all the data. So, and I think that's the beauty of the system, that please don't disturb my existing plant. Build on it rather than starting from scratch, which I think they were very well talked of, that you cannot get rid of the legacy system, neither can you throw it off. So we support, FDI supports this Namur open architecture, and we comply to the standards which have been given to us by Namur. Also, needless to say, the basic diagnostics, that is NE 107, and the 6 broad categories which were identified by the Namur group, these are also a part of the FDI, which basically means that any device which is now giving an FDI has to comply to the Namur requirements which have been laid down. Again, a picture which I think my colleague Binoy showed it a little while ago, that there is already a working system in Germany, in Karlsruhe, in Germany, where these devices are on FDI, and so is the host below. And it has been tested that, yes, it works. It works very well. And only after this, I would say many devices came into our lab for testing. The FDI registration is open, and manufacturers, in case they are here and are writing an FDI or a package on heart or something like that, can always write an FDI and get it certified. There was also a working demo model in Akima 2022, where that is last year in Germany again, where many devices from various manufacturers were plugged together with FDI software packages for each of these field devices and the host to make sure that the system is functional and is proven to one and all. You can also log into the system. In fact, there is a YouTube available. I can share you the link. You can even log into this particular system here and play with it. Play with it means basically you cannot erase off anything, but yes, you will be able to see how simple it is, and for that matter, how you see the data on the live list no sooner the device is connected. You can truncate a device, you can reconnect a device, of course, electronically. Once you do that, you will be able to see the live list. You can see all the parameters which are then visible to you from that device. So a lot more, of course, is going to come, and I'm very certain that with these changing times and, the FDI would really become a new standard for the device integration. That's all from my side. Thank you.
Thank you very much, Harish. Any questions from anybody? Anybody has got any queries? No questions? That means we all have understood. Very nice. Okay. Harish, I want to ask you one question.
Please, please.
At one point of time, we are talking about FDI. Another point of time, Divyang has said about OPAS. Now, ultimately, where are we going? Where are we heading? Why so many different platforms or systems within the instrumentation fraternity? And don't you think in all these things we need to develop new level of standards for the people to get acclimatized to what is requirement? So what is your opinion on that? What is your take? See, today whenever we talk about instrumentation, blindly we say ISA standards or IEC standards. But now when we talk about OPAS or when we talk about FDI, we come across a new level of standards, new level of requirement. Do you really think that people will get acclimatized to this, and to what extent they will get acclimatized?
Sure. Raman, see this as a jigsaw puzzle. What everyone is working upon, say for example, I'll give you a very simple example. What Binoy was talking about as Ethernet APL, or what people talk about as FDI or HART IP or wireless HART or ISA 100, all these are different parts of the jigsaw puzzle. Now, obviously, I mean, is it that the bigger picture is known, that they all have to make the systems open, number one. Number two, many pain points which Divyang talked about should get eliminated. So what I am referring to again is only one part of that jigsaw puzzle. That's only one frame of that jigsaw puzzle. And what is that? How to interface a device irrespective of the manufacturer to irrespective of the host system, which means that you have to write an FDI that no sooner I connect my device to a host system, no matter whose device it is and whose host system it is, the integration should be seamless. at just one handshake, it should happen. So what I'm addressing is only this part of it. That is the FDI, the device drivers for the field devices and for the host systems. What he's talking of is the physical layer. What HUT IP and others are talking of are protocols. So these are all different parts, and no plant is, I would say, perfect and with a requirement which is so laid down as 1, 2, 3, 4. Depending on the plant and its, of course, the topography, everything put together, you have to work on a system which is best suited for you.
Okay,
And that's how that bigger picture is important. So we only put the jigsaw puzzles, and I'm also one part of the jigsaw puzzle.
Thank you very much. Thank you. Thanks a lot. Thanks a lot.
Thank you.
Now, may I now request Srikar to please come forward? Harish, please be on the stage. A big hand of applause, please. Thank you, Harish, and thank you, Srikar.
Gentlemen, we're going to be breaking for tea. We're going to request you to stick to a timeline of 15 minutes because any which ways we are running behind schedule. The refreshment. Everyone, welcome back. Time to begin. For the next half, we're going to be talking on control rooms of the future, virtualization, digital transformation, SOS, augmented reality for maintenance, and valve automation. Our various speakers would be introduced by Mr. Srikar from Nagman Instruments. Srikar sir, over to you.
Good afternoon, all of you, and welcome to the second session of this morning Process Automation Future of Process Automation Conference. Now the topic is going to be on virtualization, and it is going to be presented by Yokogawa India Limited. There are two stalwarts who have come here, Mr. Somasundaram and Mr. Vijay. We can a small brief on these two people. Somasundaram is an executive manager in Yokogawa India Limited, Bangalore. Basically, he is a cost-conscious, result-driven engineering professional in field of automation, distributed control systems, and safety instrumented system, and 15 years of experience. And experience in all stages of greenfield and brownfield, BPCS and SIS implementation of projects. And Mr. Vijay is a manager of in Yokogawa, India, and he is a TUV certified official, functional safety engineer, and has 15 years of experience in DCS and SAS and detail engineering and application programming. Please welcome Mr. Vijay and Mr. Somasundaram. Welcome.
Good morning and vanakkam to all of you. Thank you IED Communication for the opportunity given, and thank you for the nice tea. So today we are going to talk about virtualization. Virtualization is already there in the existence. It is not new for the IT industry, but however for the OT industry, OT industry also this is already into the existence, but it is not completely implemented in Indian process control domain projects. So that's the reason we thought that let us talk about virtualization. So in the recent years, IT and OT convergence is happening very lively. So we, the OT professionals, need to understand, it is a high time we need to understand the basics of virtualization. So today, the objective of this session is to understand what is virtualization and the virtualization components, then one sample architecture of virtualization in process control domain. Virtualization is the technology that enables a single physical hardware to be used and shared by multiple logically independent systems. And basically the virtualization technology uses the software to configure an abstraction layer above the overlying hardware, and that enables to create multiple virtual machines by using the hardware resources of the single physical computer. So in a simple language, by using virtualization, we can convert the single hardware into multiple virtual machines. So what are the benefits of virtualization? Actually, the virtualization benefits are many, but here we have only thought about the benefits which is there in the process when the virtualization gets implemented into the process control domain. So reduce the number of computers, reduce the number of physical computers in the process control domain, then minimize the footprints and reduction in power consumption. Utilize full resources of the server. If we see when we use servers in the process control domain, approximately 20% of the resources are only being used. The remaining 80% is not at all used. So by going for this virtualization, probably we can completely utilize the resources of the hardware. Then take backup and restore more easily. Basically, the backup and restore methodology will be very, very simpler when virtualization comes into picture. Then reduce management lifecycle costs. Since the number of hardware is reduced, so the maintenance time and the maintenance effort is also going to be reduced, and the maintenance cost also. And lifecycle cost, as our co-speakers Divyang Shah and Harish sir told, that the Windows obsolescence is becoming an issue. So here, when we migrate to the new control system, if there is a Windows, the control system software with respect to the operating system getting obsoleted, then only this virtual machine can be deleted and new virtual machine can be re-prepared with the required operating system. With that, we can avoid replacement of the complete hardware. We can keep the hardware as it is, but only the virtual machine can be changed with the required operating system. So that's why the hardware longevity can be improved and achieve high availability. Achieving high availability, the virtual machine by itself cannot improve the high availability, but at the same time, when it depends on the configuration by which when it is getting deployed with respect to the configuration, then the high availability can be achieved. Next, we are going to talk about the virtualization components. What are the various components involved in the virtualization? First one is the virtualization hardware, host computer. This is nothing but the underlying hardware whose resources are going to be shared by the virtual machine which is created in it. Next is the virtual machine. The virtual machine is an instance of the operating system and application software which is created on the physical hardware, by using the resources of that physical hardware. Next, moving on to virtualization software. Virtualization software, this is also called hypervisor. So virtualization software is used to establish the communication between the virtual machine and the components which are there in the external network. Next, the virtualization software is used to create the virtual machines, and the sharing of the resources can be configured in the virtualization software. Host OS. The OS which is there in the physical hardware, which is installed in the physical hardware, is called host OS, and the OS which is deployed in the virtual machine is called the guest OS. Host OS and guest OS can be different, and for example, host OS can be Windows Server 2019, and the guest OS can be Windows 10 or Windows 7, whatever it is, based on the requirement, and it can be different between the virtual machines which is created in the same host server. Next to the virtual network. Virtual network is basically created by using the virtualization software. First, the virtual switch is created, and the virtual NIC for each virtual machine is created. By using the virtual switch and the virtual NIC, the communication with the external network is established. Now, for every virtual machine, one virtual NIC is created, and for that virtual NIC, the MAC address is being assigned by the virtualization software, and the IP address can be assigned by the guest OS. And the physical NIC is connected to the external network, but when the virtual machine is seen on the network by the external components, it is not that the physical NIC which is being seen by the other by the external components, but the virtual machine ka IP address which is seen on the external network. So if we implement the system properly, this can also help in the cyber security. So I mean, the system can be secured from the cyber attacks if it is properly implemented. Then moving on to thin client. Thin client is the hardware which has got the minimum functionality of keyboard, mouse, and the display, which can be connected to the virtual machine through the through a dedicated network called user interface network. And the thin client is not going to have any. The thin client operating system can be anything, and there is no relation between thin client operating system and virtual machine operating system. From thin client, we are going to take the remote desktop of the virtual machine. So operator who is working on the thin client or will have access only to the thin client hardware, and he will not have any access to the hardware, I mean the physical hardware of the control system. So in a way that is also secured. Now the system architecture. System architecture is going to be taken up by Vijay.
Oh, good morning everyone. So next time. Okay, as Soma sir told, the thin clients needs to be accessed the VMs through RDP protocol. We'll call the VMs from the RDP and give an IP address and call the VMs. There are different methods, like the methods for the VM is one-to-one connection and one-to-many. Both methods should be configured with the proper access. Okay, for the, like when we talk about the operators and the engineering groups, it has to be properly assessed. The scope has to be given proper. Okay. Next slide. Okay. Now, when we come to one-to-one connection, it is limited to one specific VM. Okay. The pros are the operator can use the thin client similar to the workstation. The cons are the thin client should be prepared for each VMs. Like one thin client is connected to the one VM. The access will be one. Okay. When it comes to one-to-many, next. The allow of the multiple VMs simultaneously by switching the display. Like one thin client can access VM1 and VM2 also. Next slide.
Actually, there are some graphics which is not working actually. Sorry for that.
Okay. The cons is the operation can be complex. Like the connectivities and the assignment of the VMs to the thin client is little complex in one-to-many connections. Next one. Okay. Now when we come to the access control, the access to the VM is limited with the setting of the guest OS. It can be allowed with the IP address and it can be specific with the Windows user also. For example, this VM1 has users of ENG01 and ENG02. Those are the users. And for VM2 also has ENG01 and 02. Now we can write a rules like allow only IP address 172.18.129.10 and the user as ENG1 here. And in the VM2, allow IP address all, allow user is ENG2. Now the thin client has an individual IP address like 172.18.129.10 and for the thin client 2 it is 172.18.129 and 20. Now as per the rules here, the thin client can access VM01 because the IP is allowed only this one of thin client 1. So 172.18 and the user is specified as engineering user ENG01. So TC1 can access only ENG1 user. Now when we come to thin client 2 or VM2, VM2 can be accessed by TC thin client 1 also because like they are specified as all users, but all IP address, but the user is specified as 02, ENG02. So thin client 1 connectivity to the VM will be ENG02 user only, whereas thin client 2 cannot access VM1. It can access VM2 only with user 2 only. Okay. Next we'll go to the example. Okay. These are the thin clients connected to the HMI network, and these are the it is the controllers and the control systems are connected. FCS or SIS are connected to it. These are the management network. This is the virtualization. I think virtualization VMs are there. From here, the thin client can connect to the virtual machine by taking up the RDP protocol. Same way with, and we have multiple screens also for the same VMs. Okay. For the cyber security and the network management, we can connect the antivirus servers, and for time sync, we can connect the NTP servers to the plant information network. Okay. Fine. Yeah. This is our slides. Thank you.
Hello. Hello. Any questions from the audience, please?
Hello, this is Ayyappan from Profi Solutions. Regarding this virtual machines, now different manufacturers like Yokogawa, Siemens also is coming with CVAS and all. What's the licensing part? If I have a thin client of, for an example, earlier we use server clients and we will installation done in engineering station and some 10 clients. How virtualization will help us handling the licensing part?
So licensing will be for virtualization machine also we need to buy a license. Here
Yes.
also we need to buy a license. It will be a similar format.
Similar. No, what is the advantage of going with the traditional server client and virtualization?
In this one, see, you don't need to have a separate dedicated workstation for all the operator stations and all. like you'll be replacing the workstations by a thin client, which is a minimum, like when you compare the cost also, it is less than what is the thin client cost. And thin client is only, it is accessing only the server, so you don't need to install any software there, extra software.
Okay.
You can directly connect, all your softwares are in the VMs, so you are just connecting to the remote desktop and you can operate the plant in the thin client.
What's the maximum clients I can go with one engineering station?
One engineering station.
One engineering station, OS, one OS and how many clients?
I mean, number of virtual machine you are asking?
Yeah, number of clients.
Number of clients, that depends on the Microsoft RDP license, CAL license. So, yeah, I think 8 per server, it can be 8 maximum.
Okay, thanks.
Like in a VM, you have multiple servers. No?
Yes,
so that
yes.
again, one VM, one server, you can have 8. So you can have multiple there also.
Okay. Why I'm asking, there is a pharmaceutical customer in Bangalore. They requested 16 clients with one. That's why.
Okay. In that case, we have to install 2 servers in a VM.
Okay.
Then they have to get the.
Thank you.
Any other question for me?
How will you handle the resource allocations when we run the multiple OS on the same machine? How the Microsoft will be handling the resources, especially on the messaging queuing services and all? How that is being handled in this VM?
Every virtual machine, you can imagine it as a physical machine with respect to, as far as the software part is concerned. So all software, suppose in the virtual machine, if you are installing Windows 10, so all the Windows security patches, whatever is applicable, same will be applicable for that also.
See, my query is, say like one of the server machine is loaded with Windows Server 2017. Okay, it is sharing the resources to multiple my SCADA servers. How the resource allocation is being handled in the VM?
Okay, the hypervisor, which is nothing but the virtualization software, that is used to configure, how many number of cores are allotted to the first virtual machine, how many number of cores are allotted to second virtual machine. So that configuration is done in the virtualization software.
But in the hypervisor, all these resources are not synchronized. So if I want to run the synchronized applications, is that possible with the hypervisor?
Synchronized application in the sense, I'm not getting.
Multiple SCADA servers applications, I want to run it in a single virtual machines.
Okay.
In a synchronized manner. Because one SCADA server can handle maximum of 64 clients.
Okay.
Suppose I want to expand my clients to say 124 or 128 like that. So in such a case, whereas all my clients should be synchronized. With the hypervisor, is that possible?
It is possible. Virtualization is not only dividing one server into multiple virtual machine. In the virtualization concept, clustering multiple servers to act as a single machine, that is also possible. And there is something called high available cluster configuration. In that configuration, we can establish a management network. Through the management network, two server or two virtual machine can be testing the health of each other by using a heartbeat signal, and then the synchronization is possible.
Okay.
Thank you very much. Just a minute, please. I request Mr. Sudarshan of MRPL, please do the honoring. Next topic is going to be very, very interesting on, especially everybody knows about it today, on AR. especially AR is being, how it is going to be utilized in terms of maintenance. That's what is going to be talked by Rockwell Automation today. I have Mr. Nikhil, Business Head, Productions Operations Management of Rockwell Automation, and Mr. Abhirath Sunil from Rockwell Automation as well. Nikhil is a business lead for production operations management suite applications. These includes manufacturing MES and IIoT, H2 enterprise analytics, and industrial data platforms. He comes with 18 years of, more than 18 years of experience in industrial consulting and project management experience in the digital manufacturing field. We have Mr. Abhirath Sunil, consultant, IIoT, AR, VR, and analytics. He is a consultant for Rockwell, specialized in innovation suite of products. They are a comprehensive portfolio that brings edge to edge enterprise analytics, machine learning, industrial IIoT, and augmented reality to operations, industrial operations. He comes with more than 9 years of experience. Welcome both of you, and the stage is yours. Thank you.
Thank you. Thank you. And good afternoon to you all. Sorry for my limited knowledge of Tamil. So, vadakkam. I think that's the only word that I know for the time being in Tamil, but probably I'll start learning more. And it's been great opportunity. It's been a great time. I've been coming to at least 2-3 events in Chennai, and a great event today by IED Communication, especially from the process automation point of view. The major thing, as I think you have highlighted, and we have been discussing on multiple occasions. So we have worked, or we have talked about the technology aspects, we have talked about the process aspects, we have talked about the profit aspects, the products aspects of it. What we have kind of limited knowledge or talked about today is about the people aspects. So what we are going to focus today is how these technologies are going to make difference in the life of people. We have been upgrading the technology, we have been upgrading lots of things on the ground in the industries, but how are these being accepted by the people itself? The point is, most of the Industry 4.0 digital transformations which are being done, either in the process or otherwise industries, only 23 to 25% of that is being accepted at the ground level or by the people at the shop floor. So major thing what we are going to look up for is how is these technology going to help our operators, our engineers who are working at the ground level. Now, as we know, I think my friends from Yokogawa talked about, so how are these going to help us? The first one at the left bottom, what you can see is how we used to connect in the past or even for now, is how I'm doing it with the clicks, basically anything with the mouse and the keyboard. So what we do it is basically we interact with the softwares, we interact with the systems, but it is with the clicks and the types. Now, next level is where we are all working right now is with the smartphones, the smart touch pads and the tablets. This is where we have been now looking at HMIs, we have been looking at all these kind of touch, talk, swipe, and this is where we are. What we are looking into the future is, can I actually, instead of touching, what I think last year or late last year, Facebook moved into or Microsoft moved into, calling metaverse. Now metaverse for a gaming or metaverse for a social is very much that they have been accepted very well. But what we are looking forward to is not in the gaming aspects, what we are looking forward to is industrial aspects of this virtualization. So where we can bring this virtual reality or augmented reality is the aspects that we're going to speak about today in specific. So I think few of us might have played this game, or at least in the younger generation, Gen Z might have looked at it. What we call it as the catching of these AR, what you can see at the top 4, these are some game where we used to go and catch. So these are basically what we used to call it as a AR. So augmented reality is nothing but putting up some virtual digital aspects into actual real physical presence. And in the second photo, what you see is basically an NVIDIA's technology, where we have been attending lots and lots of meetings during our COVID time. But sometimes we are looking at not into the cameras, we are looking at some other places. But then it loses out. What we have lost in those couple of years was a touch, what our understanding of people, what our understanding and looking into the eyes of the people. What NVIDIA has come up is basically how can I virtually make sure that I'm always looking into the eyes. So my camera can actually virtually look into it and say, okay, the person is always looking into the camera, though it is not physically actually looking it that way. So what augmented reality brings us is basically a combination of all the real and virtual worlds, where we can, in the previous slide what we saw is more about the gestures, how we can actually work with those gestures. Now, can this be possibly be done in our existence in the maintenance, especially in the process industries? Now, what I talked about on the people aspects. So, major 3 challenges that we have from the people side of it. One, they are getting older. They are not very instrumental. If my operators are working in the industry for 30 years, 40 years, how are they going to adapt to all these new technologies? Can I get new team, new people? Are they going to adapt to the older technologies? There's a big gap. And secondly, whatever knowledge I have with these 30 years, 40 years operators and workers and engineers and managers, how can I capture that information? So all that we have done is we have increased the complexities of our products, the processes, everybody. We have, by doing this, obviously we have increased the time and the cost of the training itself of the people. But how I can retain that knowledge, that part of that 40 years of experience, how can I bring it back? And last is obviously I am definitely looking at the safety of my people, because safety is the topmost concern, whether it is a process industry or manufacturing. So how can I make sure that all that he is actually going to open is not going to make his or her life difficult? So that's the overall idea about the AR in manufacturing. So what we have seen till now, AR has been instrumental not only in the maintenance, but all the 4 business aspects of the industry. Starting at engineering, we have been doing lots of virtual team collaborations, virtual engineering, in fact, we have something called as a virtual factory and virtual refineries, where we can actually digital twin the whole factory, and somebody can actually remotely look at how and what things are going on at the factory level. As I think some of my friends have talked about, we are using these technologies for a monitoring aspects and not the control aspects. Majorly 2 reasons, safety, and secondly, connectivity. So safety is definitely one aspect we do not want to touch upon. Secondly, the connectivity and the broadband. We have good friends coming in from Jio, putting up 5G, Airtel coming up with 5G+, but it will take some time before it actually gets rolled out across the industries. So this is where we would like to have a digital factory or a digital refinery or a digital industry where we can get all the information, monitor them, but it may not be able to control the processes at the back end. Second is about the operations of manufacturing. This is where we are actually working with lots of our customers and lots of our partners, where such kind of technologies can actually write back into the operations as well, where it can actually look at and probably probe into the operators and give them an feedback saying that what are the right questions or a prescriptive analytics kind of things, where they can be given a information about what is the right lever or right I would say pressure sensors that I need to change? What are the actuators or what are the limits that I have to update? So all that can be done. Third, what is the sales and marketing people? So there was one very specific demo that we had it. It's more about aluminum can. So we go to lots of customers, they say, I want to print, I want to change the design on my can coming up for the World Cup, what recently happened in Qatar. So if they want to change, do they need to print it? So previously it used to be physical. This is where it is required. Now in sales and marketing, when you are using AR, VR, you don't need to actually physically print it anything onto the aluminum cans. You can change the design of the aluminum can and you can virtually see that how would it look like. You can actually touch with those HoloLenses and those touch sensitive hand gloves. You can actually look at the whole aspects of it. This is where it is going to be useful from the sales and marketing point of view. And definitely the topic of today, the maintenance. So maintenance, majorly what we are talking about is, one, how to capture that knowledge of my 40 years of experience from my operators. Second, how am I going to train my new operators who are coming in? And third, basically, how am I going to improve my productivity? If there is a downtime, if there is an unplanned downtime which has happened, so can I actually get in touch with an expert who is not available on site, who is not available within same vicinity or a geography? How can I get connected with that person? Can I virtually look into him and rope him in for a certain period? Maybe a 40-minute call would be good enough. But can he actually give me an expert knowledge on how to operate, how to open up a particular part of the refinery and make sure that downtime is kept to the minimum? So that's the aspects that we are going to look at it. So what we have it is, this is the, what you see in the left is basically a traditional method. If there is anything goes wrong, the field engineer or the field maintenance engineers or the people that we love the most used to open up a PDF or maybe a hard copy of the instruments and then go through all the pages and look at everything. What we're gonna try is, how can they improve? What all things and what all numbers they want, they can look at it directly, virtually, right there, probably with their own tablets, even with their own workstations. This is where we would like everybody to move into as an AR into the maintenance side of it. Now I'll hand it over to my friend and colleague Abhirat. He will walk you through on the other aspects on the maintenance.
Thanks a lot, Nikhil, and very good afternoon to all. So, diving deep into maintenance aspects, how can we use augmented reality in maintenance? So, I have 4 use cases or 4 areas where maintenance can give you a lot of value. AR can give you a lot of value in maintenance. So, they start with remote assistance, maintenance training, maintenance inspection, and maintenance guidance. So starting for the remote assistance. So from the COVID times, it is a very general practice that you reach out to a maintenance expert using video calls, right? I'm sure most of you would have done that. To reach out to an expert technician, you do a video calling. That can be augmented using augmented reality again. So using the augmented reality live annotation technology that we have, we would be able to draw annotations. So these annotations actually stick on to the areas where we draw that. I will show you a small example here. So here you open up a tab, you do a video calling to anybody whom you generally do. And once you have done the video calling, in a minute you can see after connecting, right here, the app is actually tracking the whole physical area. Once the whole physical area is tracked, the operator as well as the expert technician would be able to do the annotations. So you can see here, they are doing these markings, and these markings actually stick on to the actual physical objects. It doesn't matter if you move from left to right or if you move it from up to down, these markings stick on. So what is the use? You can imagine if you are having a big machine and you want to communicate and somebody is telling you, click on this particular button or click on this particular wire. It's very difficult to have that conversation. This technology makes it easy for you, and this will augment the normal video calling capabilities. And studies have shown that after using this technology, 84% of the people would prefer such kind of technology, and we have seen there is faster errors that are getting resolved using this technology, and 50% fewer errors occur than a normal video calling when we use the AR technology. So moving on, we have AR-based maintenance training, and of course, training is one of the biggest use case that AR has in the manufacturing industry, and that's also the case in AR, in the maintenance. So here we have usually how we do the training, you have 2D documents, and then you might have, some companies might have areas where you do the training units, and usually they are shadowed with expert technician to learn. But using AR, you can take out that cognitive stress of reading a document and then trying out it in the field by digitizing all those information. So we can provide them step-by-step procedures on how to actually work on a certain machine. And also you can have tools that will help you to capture the knowledge of the expert technicians. I can show you an example here. So in this particular example, the new joinee, or who is a novice trainee on the maintenance, is wearing a HoloLens, and he is learning how to do the maintenance procedures on a particular machine. So you can see here, using augmented reality, we can show them what are the steps, each steps that are required, what are the tools that he needs to have to perform a maintenance procedure, any supporting documents, only the required documents that we would need to understand how to do that particular operation. We can even show the internal workings of the machines, right? So that the operator who is working on the machines has a much deeper understanding on what he is doing. Like you can see it here. We can also show the internal working, how the machine actually works, what is happening inside. So all these things can be digitized and created. Moving on to the next one, it is on the maintenance inspection. So generally how inspections happen, it's a paper-based or a manual inspection. Most of your PM check sheets, right? Preventive maintenance check sheets that you have are done based on paper, or it is done based on a paper check sheets. When it is done manually, there is always a scenario that the technician might overlook some of the steps. He can skip few steps, and ultimately down the line, that skippage of few steps can lead to a downtime, right? But that's not the case in augmented reality. In augmented reality, along with computer vision techniques, we are able to guide the operator to exact points where he is supposed to do the maintenance, and we can get a confirmation also, did he do it or not. For example, here I am showing an example on a 3D printed machine. So using computer vision, we can understand what machine the operator is working on, and the first one is to ensure if that particular switch is on. So this is the first checklist. So we can get a confirmation also that he did that step or not. And then we call this as Pathfinder. It will actually help him to navigate till the area where he is supposed to do the next step. Wherever he moves the tab or device, it will always guide him to the exact areas where he is supposed to do the maintenance. And we can also include pictures and videos to help him, if he don't know, to do that particular procedure in the exact manner. So these kind of technologies can be implemented in multiple checklists. It can be done in routine maintenance inspection. It can be implemented in post-maintenance inspection, retrofit inspections, and refurbished inspections. This seems to improve the productivity by 20 to 30% and unplanned downtime reduction by 5 to 10% according to the studies. And finally, we have the AR guided maintenance. So this is the biggest, or this is the complete digital thread that we are talking. So here in this example, sorry, can we play this video? Yeah. So here in this example, you can see the augmented reality collecting the data from control systems, sending data to IoT platform. IoT platforms can do a prediction or can understand if there is a failure, and that can be highlighted using the augmented reality. So once here you can see there is a problem with that particular gear that is been highlighted, an alert is given out, and it is asking the operator to inspect that particular area. So we understand there is a problem. Now we have to do the maintenance. But before doing the maintenance, if there are some checklists like checking if the area is hot, checking some parts are movable, it's still moving, or ensuring that some readings are within the range. So all these things can be augmented and presented as a check sheet again. And we can also show hazardous areas considering the safety aspects of it. And once these checklists are completed, we can show step-by-step procedure in which the maintenance procedure has to be carried out. So here you can see which are the parts that has to be assembled, disassembled. And once you disassemble each of the part, it will show you where the problem is. For example, here the problem is with this particular gear, and then this gear can be replaced. So we can also show the replacement procedure, step-by-step procedure in which you can replace that particular gear. So this has a lot of advantages. We can increase the first time fix rates up to 70 to 90%, reduce the maintenance procedure speed by 20 to 30%, and usually the overtime working also can be reduced in certain numbers. So thank you, thanks a lot. We have most of these demos in the stall along with Multivista here. We would encourage you to come and visit the demos. Thank you, thanks a lot. Yeah. If you have any questions, we are open.
Any questions? Can you hear me?
Yeah.
Hi, my name is Kalyan. I'm from Prolifix.
Little louder.
I'm sorry?
Little louder.
All right. Keep the mic closer. Is it better?
Yeah.
Yeah. So two quick questions. One is lots of what you have shown had been possible from quite some time. And every year is supposed to be the year of AR, VR. But unfortunately that hasn't happened. Why do you think now is the time? I'm asking as an optimist. Don't take it as a negative, because it's frustrating that every year is supposed to change everything, but it never happens. That's question one. Yeah. And question two is, we had a reasonable ecosystem built around 2D tech and all that. But 3D, I mean, it's really good for demos and etc. But when someone wants to actually build something, everything seems so expensive. And how do you see this is going to get democratized? Like, say, typical web application, a corner village student can develop, but not so with all the 3D stuff that you're showing.
So I can take the second question, and I think Nikhil can take the first question. So
Thank you.
Second question was around how you can leverage the 2D drawings and why 3D is not coming into the mainframe. Am I correct? And how you can use these technologies. So as far as Rockwell, most of the tools that we have built now are on a low-code, no-code kind of environment. So anybody with process knowledge would be able to use these tools so as to build these technicians or so as to build these SOPs. And many products that we have are SaaS based also, so you don't have to physically install any softwares in your premises. Everything is taken care by us. All the upgrades, all the security, everything is taken care by Rockwell. You only need to use these softwares, and as these are low code, no code environments, it will be very easy for you. And as far as if you don't have a 3D, our partner systems are there who can help you in building those 3D models, and you can always use our platforms.
So answer to your first question, I think you asked why it is that the adoption rate is low. I'll just put down some numbers from the industries that we have it. Before 2019, the adoption rate was as low as 2%. Thanks to COVID, on the other way, because of all the virtualizations that's coming in, AR, VR adoption rate, not only in the developed economy, but in case of India, we have seen adoption rate of as high as 25 to 30%, considering the scope of the industries that we are looking at. It's a change, it's a disruption. EV cars are there since long, just like what you mentioned about the AR, VR. But how much is the adoption rate, be it in North America or be it in India? Likewise, it takes time for any disruptions to change. It will take change, but it will, with you and probably with us, I think we are the enablers to make sure that this happens. Yeah, any other questions?
Hi, sir. Nagaraj here from LPCIT. Yeah, actually, we have seen, previously I want into maintenance. I have seen many machines, legacy machines, which need to be converted to here. The challenge is like 2D, you will be having the drawing. Then any tool to convert into augmentation.
So the question was, how do we convert the 2D to 3D? Okay. So as I told, there are partners, specialized partners we have. Even if you don't have the 3D drawings, they would help you through different technologies, including scanning, to convert 2D drawings into 3D. And recently, I saw a new product or a new technology using the generative AI, which will actually look at the 2D drawing and it will automatically generate the 3D drawings which are required. So hopefully that will also come soon in the future.
Thank you for your wonderful presentation on AR. I request our Mr. V.P. Raman to come and facilitate the presenters. Thank you, Ram. Okay, this is going to be our last presenter, and you know very well everything whatever we do in terms of augmented reality or OPC servers and connectivity, etc. The final thing is it's only on wall. So finally, controls systems are going to operate with the developments in the valves also. So I request Mr. Rajendran to come and present on valve automation. A brief introduction of Mr. Rajendran Damodaran. He is working with Sovereign Gokon for the past 13 years with overall experience of more than 20 years. And he is an expert in control valve application, engineering activities such as valve sizing, etc., which is all the more important for the correct control ability. And he has worked in most of the oil and gas, downstream and upstream fertilizers, desalination plants, air separation units, etc. He is currently handling the key account management for oil and gas and air separation industrial segment customers. Thank you very much. Welcome, Mr. Rajendra.
Vanakkam and good afternoon. Good news is that this is the last presentation of this session. I'm going to touch upon the basics and glimpses of valve automation. Nothing is very new. I'm trying to give you the basics so that you can connect with your industry requirements and other things like that. Okay, I will keep in this mode because this is not moving. Okay. Just giving some representation of manual valves versus automatic valves, where manual ball valve, globe valve, and manual butterfly valve is shown in the left side, whereas right side we have shown the pictures of automatic valves by using pneumatic type of actuators. control valve definition is, as per ISA, control valve is a power operated device that modulates the fluid flow rate in a process control system. Control valve is basically an assembly that includes at minimum a valve body assembly as shown here. Then there is a pneumatic actuator and there is a positioner. Without a positioner, the actuator can be used as an on-off valve. Once we give air supply or any mode of power supply to the actuator, valve can open and close. But when we add a positioner to it, the positioner acts as a smart instrument which controls the amount of air going inside the actuator so that the valve can be throttled at various positions, like 10% opening, 50% opening, or whatsoever is it, as per the command signal from the DCS. Without a positioner, by using a solenoid valve, this can be operated as either on and off. This is a simple control loop to explain the automation requirement, where it is designed to reduce pressure in the line from 20 bar to 10 bar, where a control valve is used. This downstream pressure after the valve is sensed by a pressure transmitter, and that pressure transmitter gives signal to the controller, and controller gives 4 to 20 milliampere signal to positioner. Either it can be 4 to 20 milliampere electric signal or hot foundation field bus profibus signals as per the communication protocol available at site. Then this positioner is taking a instrument air supply, and based on the controller signal, the air supply pressure is modified and sent inside the actuator so that the valve can be open and close and can be throttled in mid position. For example, when the downstream pressure is lower than 10 bar, immediately the pressure transmitter senses and gives signal to open the valve. Thereby, the valve allows more flow across the valve, and the increased flow resulting in increased pressure, then the desired set pressure of 10 bar is achieved. In case the pressure is exceeding 10 bar, it is going above 12 bar, 13 bar, then immediately it gives the signal to close the valve. Thereby, the flow rate reduced, then the downstream pressure is also reduced. Basically, a valve is a mechanical device that can just modulate the fluid flow rate. Based on the application at which we are using it, with the associated transmitter, controller, and other system, this can be either used as a pressure control valve, or temperature control valve, or level control valve, or any other application. However, the valve, without actuation and associated instruments, it can be just modulate the fluid flow rate. Only the application is made by the valve, the way we design the complete loop and circuit with the transmitters and controllers. Valve type selection based on application. We have broad category of valves. One is rotary valves like ball valve and butterfly valve, and linear type of valve, globe valve. What we can infer from the pictorial representation is that in rotary type valve, ball and butterfly valve, the fluid is taking a small deviation into its flow stream or flow pattern, and then it is reaching the downstream, if you follow the arrow mark indicated here. Similarly, butterfly valve also, it is taking a small deviation and again regaining its original flow pattern and flowing in the downstream in the rotary valves, ball and butterfly. Whereas in a globe valve, you can see that the fluid has to take minimum 90-degree turn to move from its bottom chamber to the top chamber. That's how the globe valve is designed. After moving from bottom chamber to top chamber, then the fluid has to diffuse circumferentially surrounding the cage and the plug 360 degree, then it will reach to the downstream. Thereby, as a minimum, the fluid is taking a 90-degree turn, and then it is circumferentially diffused all over 360 degree, and then it is going into the downstream. Thereby, the pressure reduction in globe valve is much, much higher compared to ball and butterfly valve. That is the reason globe valves are used for high pressure drop application and extremely severe and critical applications in the process industry, whereas ball and butterfly valves are generally used for low pressure drop application and higher flow rates. Actuators can be broadly categorized into pneumatic actuator, hydraulic actuator, and electric actuator. And pneumatic actuator is the mostly used in process industries that can be categorized into linear and rotary type. Linear again can be categorized as piston type and spring and diaphragm type. And this rotary actuators can be further categorized based on its design and components used, either rock and pinion actuators, Scotch yoke actuators, vane type, and helical type actuators. These are the pictorial representations of spring and diaphragm actuators and piston actuators from pneumatic actuator family, where the pneumatic air compresses or expands the diaphragm by compressing the spring. That's how the actuator stem moves up. Once the pneumatic air supply is cut or exhausted, the spring will make the valve to its original position. These are the fail-close actuators, where the spring is placed above the diaphragm so that it will be able to achieve its close position in the absence of air. If it is fail-open actuators, the spring will be placed below the diaphragm. Here, the diaphragm is just replaced by a piston. Therefore, it can be used for higher actuating pressure, instrument air pressure. If it is more than 4 bar, 5 bar, up to 10 bar pressure, the piston actuator can be used, and also this can give longer stroke length for the valves. Then in the pneumatic rotary actuators, this is rack and pinion type, spring return type, and compact Scotch yoke actuators, and large Scotch yoke actuator which can be coupled with rotary type of valves. These actuators can be coupled with linear type of valves. These actuators can be coupled with rotary type of valves. Valve mounted actuator pictures: a globe valve mounted with piston type actuator. A butterfly valve is mounted with Scotch yoke pneumatic piston type actuator. Then we have hydraulic actuator, which is in construction wise very similar to pneumatic actuator. Instead of pneumatic supply air, we can use hydraulic oil. So the actuator will have inbuilt hydraulic reservoir with inherent pump and motor. That pump and motor system increase the pressure of the oil and then send within the actuator cylinder. Thereby, hydraulic actuators are used to generate very high amount of force compared to pneumatic actuator. Pneumatic actuators generally, the actuating media can have a pressure of 4 bar or 5 bar pressure as per the instrument header pressure in the process plants, whereas hydraulic oil can be pressurized up to 200 bar. Thereby, it can produce very high amount of forces. Then we have other type of actuator, electrical actuator. There is no actuating medium here like pneumatic or hydraulic. Just motor supply, power supply runs the motor shaft, and that shaft is connected to the valve shaft or stem with the gear arrangements, so that this motor actuation can be directly actuate the valve. Only disadvantage with this system is there is no spring force or backup force available to drive the valve for fail-safe position in electrical actuator. Whereas in pneumatic or hydraulic, always there can be a spring which will drive the valve to fail-safe position. So mostly electrical actuators are fail-stay put actuators. However, newer technologies are coming into electrical actuators with the inbuilt capacitors which will store the power or energy which can be drive the valve to fail-safe position in case of power failure. These are some of the self-contained electrohydraulic actuator types for linear valves and rotary valves. Complete cut section of the valve and actuator pictorial representation. Up to this part, this is actuator. It sits on the valve where any movement in the actuator will pull the valve plug by this stem connector or stem coupler. Thereby, the valve plug can move up and down to control the process fluid or to shut off or open the valve. This is the trim flow characteristics, because in automation, valve characterization is also required, flow characterization. When we open the valve for 20% opening, if we get 20% flow, and if it is a linear increment like this, for example, at 50% of valve opening, when we get 50% flow, this is called linear flow characteristics. Then quick opening characteristics. The moment we open the valve for even 20%, it allows more than 60% of its total flow rate. This is quick opening or on-off flow characteristics. Then one more characteristics with a wide rangeability is that equal percentage characteristics. Even when we open the valve for 40% opening, it allows fluid less than 25% of its total flow rate. Thereby, this trim characteristics or trim flow characteristics is widely demanded by most of the process applications because it can handle a very high rangeability. How do we achieve that different flow characteristics in the valve is like this. Within the valve, when we have a flat plug and seat, the moment plug lifted from its seat, it allows the entire process fluid to pass from upstream to downstream. That is how quick opening characteristic is designed in the valve internal. Whereas in linear characteristics, the plug is having a contour profile. That profile allows the only controlled amount of fluid to pass through the valve. Even the plug is opened almost 50% of its total opening, because this is the seating area in the plug. From its seat, it is almost open 50% of its total flow rate. Still, it allows only the controlled amount of flow to happen through the valve. This is linear characteristics. In equal percentage characteristics, the contour profile is further designed to control or allow only limited amount of fluid to pass through compared to linear flow characteristics. That is how equal percentage characteristics is designed in the control valve. When we just look at the graph, this is linear, this is equal percent, this is quick opening. We are achieving that different flow characteristics by the way of designing the trims differently. Then valves will also have multi-stage trim design for high pressure reduction. These are the simple cage valves for very low pressure reduction. Then drilled hole cages to diffuse the process fluid into multiple small streams, thereby to kill the energy in a better way. Then we have multi-stage pressure reduction. For example, we want to reduce the pressure from 300 bar to atmospheric pressure in a single valve. Then we need to have a sophisticated flow control trims like this. Thereby, the pressure will be reduced step by step. Then we have multi-labyrinth trim for very high pressure reduction. Then further stepped trims like this. Then pressure balanced design facilitating compact actuator. This is a very simple and standard control valve trim components generally used. But the problem of this unbalanced design is when the process fluid pressure is very high, this process pressure can probably lift the plug, or else we need a very strong actuator to sit on the plug. strong actuator in the sense the air supply or power supply to the actuator should be very high, or the actuator area should be disproportionately very large than the valve. To overcome this, we getting into balanced design of valve, where when the valve is in fully closed position, the fluid pressure is passing through the balancing hole and stays at the top of the plug. Even if we consider 100 bar pressure or 200 bar pressure acting upward, in the unbalanced case that 200 bar pressure was lifting the plug, whereas here the same 200 bar pressure passing through the balancing hole and stays at the top of the plug. So the pressure is balanced in both the direction, upward as well as downward. Thereby the pressure unbalance force is balanced here. So smaller actuator or a compact actuator can control this kind of design. Similarly, in butterfly valve application, to reduce the torque, valve torque, triple eccentric valves are designed so that the valve can be easily break away from its seat and will have a very smooth contact with the seat when it is in full shut-off position, full shut-off condition. Thereby, it can give a better shut-off class. These are the valve accessories for automation. For on-off valves, just these solenoid valves are used to allow or cut off the instrument air into the actuator so that the valve can be in open or closed position. Whereas in control application, positioners are used in place of solenoid valve, because in the on-off valve, we intend to either give or cut the power supply to the actuator. Whereas in control valve, we want to throttle the valve by modifying the airflow into the actuator. Then positioners are used. Pneumatic positioners with HART protocol or foundation field bus protocol or conventional 4 to 20 milliampere control system is used for pneumatic positioners. Then we have limit switches to monitor the position of the valve, on-off valve, either to understand whether the valve is in closed position or open position. Then we have a position transmitter which continuously senses the valve stem position and gives the feedback about the valve open, closed position as well as the intermediate positions. And we have further accessories in all valve automation, air filter regulator to filter and clean the instrument air just prior to the valve or actuator. Then volume boosters are used to multiply the volume of the air going into the actuator so that fast open and closing can be done. Pressure relief valve, in case of excess pressure, that pressure will be released to safeguard the valve accessories and the diaphragm. And solenoid valve with integrated spool valve to facilitate a high flow of actuating air in on-off valve applications. Then this is the simple pneumatic hookups of on-off valve, where the instrument header pressure is first controlled by an air filter, which can fixed for a set pressure. Then that air is allowed through a solenoid valve into an actuator. When the solenoid valve is energized, the air will be allowed into the actuator to open the valve. The moment solenoid valve is de-energized, the actuator air will be exhausted so that the valve will go to its closed position by spring action. This is the control valve hookup, where the solenoid valve is just replaced by a positioner. That positioner gives continuous signal or continuous air supply to the actuator for throttling the valve. This is sophisticated automation system followed in compressor anti-surge valves, where the actuator is having multiple accessories including air filter regulator, positioner, volume booster and spool valves, so that valve can be operated within 0.1 second dead time and less than 0.5 seconds trip time, which is the requirement of compressor anti-surge applications many other times. Okay. Thank you very much for your time. In the short duration, we could just present you the glimpses. If you want to understand more about the valve application, please reach out to us. We are happy to come and conduct a presentation at your premises. Thank you once again.
Any questions? Anybody? Well, then in that case, Saisha, I'm going to request you only to please felicitate our speaker.
Thank you.
Thank you, sir.
I request Mr. V.P. Raman to come over stage, please.
Well, since nobody asked a question, I would like to ask some questions on control wall. Now you said that you have got a high pressure control wall to dropping the pressure from 300 bar to atmospheric. Now when you do that, because of the Joule-Thomson effect, your wall will be coated with totally ice. So how are you controlling the brittleness of the metal or the metallurgy and to ensure that the controllability is not lost?
To counter the Joule-Thomson effect and ensure the brittleness or material to withstand brittleness, we always select basically a valve trim material with stainless steel SS316, which is having a highly impact resistance even at that cold temperature. And to avoid Joule-Thomson effect inside the valve, which can, as per this application, which can be counterproductive for the valve control application, when we design the trim, the trim profile is designed with the expanding flow profile, so that the velocity, the multi-stage trim provides path to expand the flow area, thereby the increase in velocity is taken care, thereby the Joule-Thomson effect is not adversely affecting the valve functionality. Okay. It is always the area in which the fluid passes, the area from first stage to second stage is higher, second stage to third stage is further higher, third stage to fourth stage is further higher, so that it gives way for expansion. It is not getting condensed or getting cooled abnormally to obstruct the fluid flow.
Normally in offshore platforms, where we drop the pressure from 900 psi to atmospheric, which is very high, we have a facility for injecting methanol. The objective of injecting methanol on the trim is to ensure the proper lubrication of the trim and at the same time minimize the friction whereby the trim does not get damaged when the valve is opening. Do you have any such facility in your walls?
Methanol. Okay, methanol injection and other thing are the practices followed earlier, but with the latest development in valve metallurgy, the stem finishes are maintained very smooth in order to avoid any friction. Okay, there will be friction that is giving the additional load to the actuator, so that the actuator will take care of the friction. However, to minimize the effect of friction, we always go for the smooth finish in the stem, as well as nowadays all gland packing metallurgy which is chosen, or self-lubricant material like PTFE, or even graphites are having some additives so that the friction is taken care. Earlier days, like very high frictional material like asbestos and other things were used in gland packing. Now with the use of latest metallurgy, the friction is taken care, which doesn't require generally a injection of anti-frictional elements.
Thank you very much. So we don't want to stand between what is being technically discussed and what is waiting for us outside for our stomach. So with this, we conclude our technical session now. 1 minute. Before we conclude, we would like to honor Mr. Rajendran.
Sir, along with the token of appreciation, Dr. Raman had questions for you as well. So we are glad we gave across both to you. So please, both of you. Raman sir and Sai sir, we're really thankful to both of you for being present here. Without the two of you, we wouldn't have been able to take this session forward smoothly. We owe that success to you. And finally, I'd like to hand over to Jyoti to thank everyone on behalf of ID.
Good afternoon, ladies and gentlemen. So I'm sure from 10 a.m. That you have had a very interesting time. So firstly, I'd like to call upon Dr. V.P. Raman and Mr. Sai Ramesh. Sir, please come forward to the dais. You have been chairing the entire session. So on behalf of ID Communications, we would like to thank you by extending a small floral tribute. So we have Ms. Krisha, and she is also Team IED, who is felicitating Dr. V.P. Raman as well as Mr. Sai Ramesh. They are on our steering committee as well as on the Board of Governors for Automation Expo South. So just a small introduction, the Board of Governors are 14 people in Bombay and 14 people in Chennai and 39 people for the Mumbai edition. We have been meeting every month to make sure that the conference as well as the exhibition is a grand success. Thank you so much, sir.
Thank you very much, Jyoti. Thanks a lot.
Thank you. Thank you. So on behalf of ID Communications and the Board of Governors for Automation Expo South, I'd like to thank Mr. Binoy, Mr. Divyang Shah, Mr. Harish Wadhwa, Mr. Somasundaram, Mr. Vijay, Mr. Nikhil, Mr. Abhirath, and Mr. Rajendran. All of you fantastic speakers, and the thing is that you all managed to keep the crowd right here, so I'm sure that it has been a very interesting time. And of course, I have to say it is the first time that we had the first three, before the tea break, a session on platforms. We talked about APL, we talked about OPA, and we talked about FieldCom. So this was a dream that we always thought to do it in Bombay, but we managed to do it in Chennai. So kudos to all the delegates who came in here to attend this and the other speakers also. So we talked, this conference was on future trends in process automation. As I said in the welcome, there is a future and it's going to be different. You have to create that future. So we talked about the future here, and we are going to see futuristic technologies then. So just a 30-minute break and we are back in here to talk about future factories. Thank you once again.